So we have two SEGA Naomi 1 systems. One has virtual tennis installed and the other has a shootout pool prize. Not an amazing game, I'd imagine. Basically, how this is going to work is I need to clean them up first and kind of just get all the grime and the dirt off them so I can work with them a bit more.
The Naomi hardware is quite unique in that it's not JAMMA, it uses the JST standard. Now, I don't have any arcade equipment around, so this project is going to be unique in that sense, that we're going to have to build a lot of stuff and find solutions as we go along. So with that in mind, there's going to be a few different sections covering this in the video. First, we're just going to inspect and clean up the units. Next, we look at options to power them using the JST-VL power inputs. Then we're going to look at an I/O board, and in this case, a Tucson Logic JVS-Bridge. Then we need to look at the controls that we're going to hook up to the I/O, and we're going to use BD15 adapters to hook up an arcade Fightstick that we're going to build. It's only once we have all these things together that we can actually do the initial testing of the system and find out what kind of faults there might be. Then we're going to remove the supercapacitors. This should be done on all SEGA Naomi hardware if it hasn't been done recently. Then we're going to move on to the repair and the actual rework of the PCB. We'll also be replacing some of the exhaust fans in the units because the old ones can be quite loud.
So I have the two Naomis apart. The boards have been cleaned. These I cleaned with Vanish Oxy Action and some water, and then Magic Eraser to get kind of the heavier stuff off them. So they're looking good. Still a few little bits here and there, but they're looking pretty good. Fans cleaned up on that one. Yeah, I mean, I'm not going to try and adjust it. I will just test them out. This Naomi's console was particularly dusty, but yeah, they've cleaned up pretty good. So I'll just in case there's any residual water, I'll give them another while to dry and then I'll reassemble. So back in handheld mode here again. It's a few days later, and I just wanted to show you these basically JST to ATX kind of harnesses or converters, cables that I got from Erkin Labs. I was going to crimp up some myself, but these terminal blocks, these connectors, are not in stock, and they're not going to be back in stock late 2022. They're not cheap either, so it actually worked out great getting these from Erkin Labs, and they're really good quality. They've got that nice kind of he's used that nice kind of cable in them. So we can't power on or test them just yet, and they won't actually go well until we have the I/O hooked up. So the JVS-Bridge boards arrived today. Now there's email addresses on this as well as some information, so I'll just put that to the side. Don't want giving away details. Same reason I opened the box first. So we'll take the boards out and we'll have a look. Now this got caught in customs where it sat for about a week. Tucson Logic was fairly quick in getting them out to me, so totally not their fault. So there you can see our USB. Well, it's not actually USB, it's a physical USB cable, but it doesn't use a USB communications protocol. It uses something completely different. But yeah, that's where we'll plug in our cable from our SEGA Naomi to this JVS-Bridge from Tucson Logic. Okay, so here are the two boards. And if you'll notice, we have player 1 and player 2. Now you can update the firmware on this so that you lose the 2-player, but you gain more buttons. You can see here it says warning, never connect JVS port to a USB host, because this is completely different. It's JVS. Even though it uses a physical USB type A header, it's not. Even though it looks like your standard printer cable header, it's not. So yeah, and this is where you power the unit. I think that's also where you plug it in to flash the firmware. So with my setup, I'm going to need coin and
the standard up, down, left, right. Punch 1, 2, 3, click 1, 2, 3, coin in and start. How am I going to go about this? Well, I have these little DB15 JAMMA arcade stick style male ports, and the idea here being that if I crack one of these open, clip here on the side, you can see we have our screw down terminals. So if I wire one of these to our board, the wires that come out here on little header pins that I can stick on, and that'll allow us go from our Fightstick to the JVS-Bridge. So this is the terminal that will live inside the Fightstick, and I'll connect it using this DB15 cable. So basically, yeah, the Fightstick isn't married to this system, and neither is this. I can quickly pull it off and disconnect and do something else. So what we're going to do first is I'm going to crimp up some leads. So basically I'll get the pin out for DB15 JAMMA, and I'll get some, I guess, yellow wire for kicks and blue for punches, and I'll label them up, crimp them up, get them married to the terminals here, and get them populated across here. So it ain't pretty, but there's the adapter. So we're going from DB15 to our Tucson Logic JVS-Bridge. So with that said, on the back of the silk screen, you will notice we have player 1 mark out. As you see here, it says 5 volt and ground. So what I want to figure out is, okay, which orientation is that silk screen? Is it, what makes sense? I did solder on the 2 pins here optional for supplying the board with 5 volts and ground, because I think I'll possibly be doing it that way. I don't know yet. But if I go into beepy beep mode with the meter, and if we go to ground here on this pin, and I want to check, okay, so yeah, with this translates to this, and I take it that's 5 volts there. Yeah, so we know that that's the silk screen here matches it, flipped over like that. So I'm going to move my meter out of the way again. So let's start hooking things up. So first we have 5 volts and ground. So that's all our connections made. So as you can see, that's not the prettiest thing in the world. So there you go. Yeah, very ugly solution. But you know what? Just for testing, it's fine. So you may notice that I have a wire soldered from here, and it goes to the terminal block 1 over here. Well, the reason for that is on the DB15 connector, the actual ground pin, which is over here on the opposite side, isn't connected to anything in the Neo Geo and the kind of JAMMA kind of wiring for DB15. So that means that this is left floating, and that's not a great idea. So pin 1 is ground on the DB15 for JAMMA. So I've just soldered a wire from there to there, and that should do the job. This little retention thing isn't great. The screws that go to it run close to the wire. So in a permanent solution, obviously I probably have longer wires just to make this a bit more malleable. But you'd want to run some heat shrink over them, and that's possibly what I'll do once I do a more permanent kind of solution for this. But this will be fine for testing. So yeah, just close it up there. So moving on. So sorry about the shine there, but here we have the arcade stick. So you can see I have my 6 buttons here for punches and kicks. I have a coin and select or start, and my 8-way gate arcade stick, which is weird. It's this alters the type of restrictor, plate. You can just, other sticks, you just replace this entire transparent bit here. This one, you just kind of move this around and it kind of alters the gate. I guess it's cheaper. It's kind of silly. So with these, what we can do is, I have a ground harness. I actually had it on, but I took it off because, I need access to these at the moment. I'll put the ground harness on last. So here's one of our switches. Top point here is ground for the switch, and then we connect here to the spade. Now I have like spade connectors for the grounds, but I don't have for these. So we're going to solder and put a wire through the loop, wrap it, and solder it on. This side one, this is ground for the 12 volts, and or for the LED, and this is 12 volts here. We'll see about adding the 12 volts because I can come along and put that harness over the top here. If I do that first, I'll block access to this. So I'm going to wire up the switches. If I get it working, then we'll come back and we'll add the illumination. So again, sorry for the glare here, but I just want to show you buttons. So I've got the wires soldered on, and I've tinned the ends. I should have my flush cutters here, so I probably have a little bit too much here, but I can trim them off. But the idea being is that I'll show you the wiring diagram for this, but the idea being is we're going to go through them all and wire them up. So first I'm going to start with P1, punch 1, or is it punch 2, which is on pin 5. So I'm going to need a screwdriver as well. So we'll go to 5 on the terminal block. Actually, I should really do it my way rather than their way. Okay, I'm going to start with punch 1, which is pin 13 on this terminal block. So I'm going to get my button, up it in there, 13, tighten down the terminal. It's crooked. And there we go. First punch done. Which way do I want this? There we go. So that's our first punch. So there we go. I've got it all wired up. The JVS-15 is secured through 2 bolts through the bottom, and then this case, which is really shit, is just bolted on. Yeah, maybe the top is worth it, but at the actual bottom piece, you know, this really isn't worth it. But yeah, I got the buttons as well from Arcade World, I think it was, in the UK. Yeah, you could possibly get the ones that come with the Amazon set. You know, they're probably made to fit it a bit better.
So apologies for the noise and for the flickering on this screen. As you can see, I just have this Naomi in RAM test mode. Yeah, it's got some bad ICs there, so I'm going to make a note of those. Its fans are working, everything else is fine. Yeah, the problems you're seeing with the pictures related to the RAM fault. So you can see there I've got my JVS-Bridge hooked up to my controller. Haven't really had a chance to use the controller, but you know what, I just have it hooked up. I'm using a 750 watt Corsair semi-modular power supply there. It's doing the trick. I'm pulling 5 volts and ground to power the JVS-Bridge from the header here at the back. So I'll make an actual permanent kind of harness for that later on, once I come back to sort out the kind of adapter here and tidy it up. But yeah, I mean, it's working. I kind of expected some RAM errors. It's quite common on the SEGA Naomi to have RAM errors. I should be able to fix those, either pull chips off of graphics cards or I'll be able to order replacements. So this one has a fan. One of the fans isn't working, this exhaust fan, and I don't have a game in it at the moment. I'm just doing a RAM test because I know the game works as such. This one doesn't seem to have the same problem. The text and stuff is still very kind of flickery, but I'd say there's a RAM fault, alright, but probably not the same chips. Yeah. Also, we'll take a closer look at these boards when I'm reworking them, but I'll zoom in there. You can kind of see by the EEPROM in between the battery there's a supercapacitor. That'll need to come off and definitely be changed. So yeah, I'll wait till oh, it's come up. IC22 is bad. So yeah, and yeah, I think it's just froze there now. That's not good. Okay, so we have the number 2 system out here. That's the one that's missing, or has missing rather. It has bad ICs, 16, 18, 20, 22. I suspect probably more than that, but once we start replacing them, we'll find out for sure. Okay, so I need to tear this down. So give me a second. Come on. These can be a pain to get out. There we go. So this is literally, this shootout pool prize is literally a dust cover. Okay, so what we need to do now is take off the actual mounting points. And I have these swapped around just so that this point is pointing in, just because they take up less space this way. So from memory, this one was possibly it's actually working a little better for whatever reason, I think, but it's just, yeah, the actual, it was dustier, it had more signs of wear and tear inside. Okay, so that's the brackets off. There's 8 screws now. Some of them kind of, I don't know if we call them captured screws, but they don't come out all the way.
we go. I'm going to disconnect the fan over here. So here you can see the DRAMs arranged around the main processor here, and there's also some on the reverse side of the board. These are Hynix branded ones. They're 512K times 16-bit synchronous DRAMs. So I may have some on some graphics cards. So I'm going to put a little X on this. To mark that one as bad. And that looks like an X. Keep going. What's the next one? Do the same here. So those four are definitely bad. The others are reading good. Should be no problem swapping those out once I get the hot air to them. So that's that board. So I know on the other one that I'm possibly going to have to replace IC20 on the other board. So yeah, and I'm, once I replace IC20 on the other one, because it was hanging after that one tested, it'll probably want me to replace the others too. So I'm just going to leave this to the side for the actually no, it can sit there for the Tipex to dry. But and Tipex isn't a great idea. It's just I don't have one of those white pen things that's very similar to Tipex in a way. But yeah, so I'm going to have to source some of the RAM. I may have some on some graphics cards. I'll take a look through my kind of junk parts to see if I have. I wouldn't be surprised if I did. But if not, I'll have to order some. But yeah, coming back to the memory here. I was going through my parts and I don't have anything that really matches this. Also, it's a memory configuration that really isn't that common nowadays. You're not really going to find them in that size, so unless you're pulling them off spares. So I've gone and done something that I didn't really want to do with this project, but I've ordered some chips from China. So we're going to have to wait about a month, maybe more, for those ICs to come. So it'll be the new year, perhaps, before those chips come. Okay, so it's going to be a while before our RAMs arrive, but I did get some supercapacitors. So what we'll do is we'll have a look at those. Remove the super caps, examine the traces in and around, make sure there's no damage, and then put on the new ones. Okay, so we've just got to get the main board out now. I'm going to remove this fan because I want to give it a full service. I just gave it a general kind of a clean before. I'm going to try and see if I can clean it better and grease the bearings and stuff. Now I would try and straighten this, but this is a BGA package, and I'm already nervous enough about these RAMs when it comes time to replace them, heating up this area of the board. Because BGA, there's nothing I can do really with my current hardware setup and tooling to fix it if something goes wrong with that. So our attention is turning to this side. Unfortunately, let me zoom in a little. Okay, so we have our supercapacitor here, this guy here. So we'll just flip it over and use the desoldering station to take it off. But yeah, it's still kind of dusty in and around there. These are the battery terminals for the CR2032, and this is our supercap terminals. I'm nearly sure that's what that is. Yeah, so first things first, I probably want to add more solder to that.
So the supercapacitor's off. You can see the spot it came out of here. It needs some cleanup. Yeah, working on that, desoldering there, it felt more like one of the ATX boards, like a Pentium 4 board that I was working on, as regards like heat soak. So another thing too is you could possibly cut the leads off one side of the supercapacitor and try and cut it out. That way you're just left with small bits of the leads in the through holes. That way, you know, there's less, it's not going to sink as much heat into the actual device. Now, if I flip it over, look at that. That was just about to cause us some serious problems. And I imagine these traces here are the ones you have to worry about. So let me do a little bit of cleanup here. I think this blackness we're seeing here is actually part of the Canada super cap. So it was just about to cause us a bad day. A little bit of a clean just before I put in the new one. That through hole isn't looking so smart, so I'll take it easy on it. You can see more of this black crap, which is something that reacted with the flux in the solder. Poke it with my tweezers, maybe. Oh yeah. Straight up burnt flux. And probably some of that battery crap. So when it comes to putting the new one on now shortly, I'll be sure to get my flux out and just syringe some through the holes or just dip some on the actual leads of the device. So let's have a look. Okay, so here's the old cap and the new cap. So it had this striped line going down here, so I wasn't quite sure. So I double checked the data sheet. Yeah, it's the same. This is this longer side wraps over the top is the negative, and this one that comes out the bottom is the positive. So yeah, I just had to double check that because I wasn't sure. The markings were a little different. It's kind of obvious on this one because it's got that nice band with the minus on it, whereas this one just has these arrows which aren't very useful at all. So my hope here is that this will just make things a little bit easier. Just with the way this thing was soaking up the heat. Oh, I didn't think this bit would be as tricky. Okay. There we go. So that'll hold it in place while I solder it down. So let's flip things over again. Right, so that should be us for this board for now. Let me just zoom out again. So yeah, I'm going to change the supercapacitor on the other board the exact same way I did this. So with this fan, what I plan to do is get in and get as much of the dust out of the smaller areas as possible. But I've peeled back this label
And rather than go through the other side, I'm just going to put like a single drop of oil in there and leave it settle. Yeah, that's probably the best way. Once I'm done cleaning, clean up inside here a little with a cotton bud and some alcohol, and just clean all around the fan, get as much of the dust off as I can. And then I'm going to put a single drop of oil in here. I might even put a little green sticker on it saying 2021. So, yeah, I cleaned the fan, put a little bit of oil on the bearing, and I also took out the EPROMs, gave them a little bit of a clean with the fiberglass brush as well, so that's a good idea. It's well worth doing. So yeah, I'm going to put this SEGA Naomi back together, and then I'll take the other one apart, and we'll give it the same treatment. So, about a month later, and our RAM chips have arrived. First, we're going to remove that fan and prep the area for rework. If we use some Kapton tape, we can stop the small SMD caps and small components from moving around. We can also use kitchen foil to protect other areas. I've shown this type of SMD rework on my channel before, but I'll go over it here briefly again. I'd like to start by adding some flux. This helps to activate the old solder. I'll show removing the first chip at normal speed, but we'll speed things up for the rest of them. Note that the ICs closest to the heatsink may take a little longer to remove due to the heatsink itself just soaking up a lot of that heat. With the chips removed, we'll remove that old flux and add some fresh stuff before moving on to using some solder wick to clean the pads. With the chips removed and the pads cleaned, we'll start tacking on the corners of the new RAM chips. For the first IC, due to the confined space, I spent some time soldering it with the smaller tip. Not the best use of time, as it's much quicker to align the chips, tack down the corners and then just drag solder with the larger K-type tip later on. Again, like before, I use plenty of flux to make my life that much easier. It kinda ends up like butter and toast with these K-type tips and the new soldering station. It really is a lot better than my older one. So with the RAM chips on, we'll clean up the flux, reinstall the fan, and we should be ready to test.
Okay, so let's test this out. Things always get out of hand setting up the Naomi, the arcade stuff, because I have to hook up a monitor, just because you don't want to be using capture software and capture hardware and scalers, and you end up troubleshooting that chain rather than what you actually need to troubleshoot, which is what you've been working on. So power supply, Tucson logic, JVS-Bridge, pulling power from there. Still haven't made a lead, still using the crocodile clips. Anyways, moving along. and our monitor. Now this monitor has a problem up here sometimes, don't worry about that. And our joystick, which we made, which I hope is wired correctly. Probably not, probably going to have to mess around with that, but that's not the point. This is the point. Oakley dokley. Oh, get in. That absolutely played back perfect. So let's see. We have virtual tennis in there. So sorry for handheld mode. Yeah, I had no choice. Oh, sick. Come on, look at that. Perfect. Perfect. No artifacts. We're good. We're good. So I'll coin this thing up. Tin Henman. We'll go for Henman. Ah! Give me Henman. Against... I don't know any of these players. I'm not really a tennis person. I did play this back in the day though. I'm going to try and play this with one hand. Boom! Get out of town. Ooh. Left, yeah. Boom! Get out of town. Get him, Henman. Oh, smashed him. Okay, right. That's cool. So we've been through the RAM test a couple of times now, but I'm not going to lie, I'm delighted to have this system working. I was already on Discord bragging about it. Okay, we'll come back to this a little later, after I have a go at fixing the other unit, but I've got these fans that we're probably going to put in there. Now, after servicing the fan on the main CPU of this board, it's actually okay. It's not as loud as it used to be. It's the fan on the side, the exhaust fan, which is kind of crap. So yeah, I've got these ones as replacements. Now, they're the right dimensions except in their thickness. They're actually thinner, which isn't a big deal. We can still mount them. They're perfectly fine. So we'll come back to those towards the end, after I have a go at fixing the other system.
So when it comes to the repair of the second system, we know that we have to remove IC22, because that came up as bad in the RAM check. But if you remember back...
IC22 is bad. So yeah. And yeah, I think it's just froze there now.
The actual RAM test hung on IC17 after that. So we know we've got to replace IC17 as well. We're going to be using the same techniques as we did on the other board. So we're going to test this console out at a different location because I needed to leave my tools set up because I didn't know if I'd need to remove other RAM chips or if this would be enough to fix it. So I was absolutely astonished that we got 2 out of 2 consoles repaired. So I guess now the best thing to do is play it for a little while, but we need to get those new fans installed, the new exhaust fans. So for the replacement fans, we're going to remove the old ones. And route the new ones into place using a small bit of 3M double-sided tape. This one's used for signage. I also use it for PC case mods, and that should keep it secure. Then we're going to strip some of our cable and just splice the cable together, soldering it in the middle, using a small bit of heat shrink just to keep things nice and neat.
So there you go, folks. Our RAM is replaced. I marked them up with little green stickers and also put like a 21 on this one so people would know the rough year it was repaired or serviced. New fan. Yeah, I added a CR2032, a new one, so we should be able to retain our settings now. And we have little power cables crimped up for our JVS-Bridge board. They're a snug fit, but they do the job. Not keyed great, just with a piece of Tipex, but yeah, it's better than nothing. But at least both boards have I/O now, although one comes with a crappy shootout pool prize game. I'll see if I can do something about that in the future. But yeah, I'm going to button these up, give them a bit of a clean. They had a major clean, but I just want to kind of buff them up. And I'm also going to use some of this Aerospace Protectant 303. It's good for these white plastics. I use them on my Dreamcast and on my beige PC cases. So once you get them clean, it kind of stops them from yellowing. So yeah, I'll shut up now. I'll button these back up, clean them up, and we'll cut back to a burn-in test. So here we are with the two systems again, and the new fans in. They're not that much louder. Okay, this one of the systems, its fan wasn't working, so it's definitely louder. But yeah, they're not that much louder. Still haven't been able to test the audio. Believe it or not, I don't have RCA left and right cable, a proper one. Yeah, I'll have to pick one of those up before I can test the audio. So, burn-in test on the other unit, and as you can hear, the fan isn't as loud as it used to be. Noticeable, but definitely a lot better since I serviced the CPU fan and put in the new fan. So yeah, we're going to leave this running for a while, for about an hour or so.
So both of our Naomi units have passed the burn-in test. I'm still waiting on some RCA audio cables so we can test the audio and set up for some direct capture. That does mean, however, that there's going to be a part 2 to this video. I had hoped to get it all done in one video, but there should be a second part where we'll do some direct capture and test play both consoles shortly, sometime in the new year. So to summarise, we had RAM faults on both systems. This seems to be quite common on Naomi. As the original power supplies that came with the units age, the 3.3 volt rail creeps up in voltage. The memory, being a 3.3 volt part, is really susceptible to overvoltage, so more than likely it's old power supplies that killed these units. There is a school of thought out there that says you should try and use the original power supplies. I don't really agree with this. I think you're better off using a modern supply. Most modern supplies deliver more than enough power down the 3.3 volt rail and are going to be far superior to 20 odd year old power supplies at this stage. So if you go for an EVGA, a Seasonic or a Corsair power supply, you're going to have a far better time. The older JST type power supplies can be used if you're going to give them a full service and fully refurbish them, but I think all in all you're better off using a modern ATX power supply. So it's great to have two working systems. I'm quietly confident that our audio probably will work, so in part 2 we'll fire up both Naomi's, we'll play some virtual tennis, we may even check out that crappy shootout pool prize just for a laugh, and we'll do some direct capture. Well guys, that's been our look at the SEGA Naomi. Thanks for tuning in, and I'll chat to you all again.